Good morning, everyone. This is the lecture over 3.4. I did put this out last week, but for some reason the video didn't show up with it, so I'm re-recording it. Okay, so in 3.4, we're talking about the rational zero theorem. And when you're looking at the rational zero theorem, you're looking at what are the possible zeros of that function. Instead of saying it could be anything from negative infinity to infinity, we could narrow it down. And it's the factors of, so I'm going to use FOF to represent factors of the constant or the term without a variable over the factors of the leading coefficient. And the leading coefficient is the coefficient of the term with the highest power. So my constant is 4, and my leading coefficient is 1. Okay, so what can you multiply to get 4? Well, you can do 1 and 4, or you can do -1 times -4. So when you're looking at these factors, you're always going to say plus or minus. So for 4, it can be 1, 2, and 4. For 1, it's just 1. And then you do your division. So 1 divided by 1 is 1, 2 divided by 1 is 2, and 4 divided by 1 is 4. So there's your possible zeros of this function. So instead of looking at negative infinity to infinity, we have 6 numbers to consider when we look at what are our possible zeros. Okay, let's look at the next one. A constant is 2, and our leading coefficient is 15. And that's a bad F there and there, so let's rewrite that. Just so when you're looking at it, it makes sense. So what do we multiply to get 2? 1 and 2. What do we multiply to get 15? I guess I need a 1 up there, don't I, guys? Well, for 15, it can be 1, 3, 5, and 15. So let's do all our division here. 1 divided by 1 is 1. 2 divided by 1 is 2. 1 divided by 1, or 3, sorry, is 1/3. 2 divided by 3 is 2/3. And then you have 5. So 1 divided by 5, and 2 divided by 5. And then 1 divided by 15, and 2 divided by 15. So there's our possible zeros for that function. Questions? Okay, so find all the zeros of this polynomial, okay? All the factors of 6. And it does not want to work with me today. Over all the factors of 1. Factors of 6, 1, 2, 3, and 6. Factors of 1, 1. So doing my division, 1, 2, 3, and 6. or my possible zeros. But this actually says to find the zeros. So to find a zero, now you pick a number. What do you want to try? I'm going to try 2. And I do my synthetic division. So I have the coefficients 1, 2, 1, 2, -5, and -6. So the first number comes down. You multiply, add, multiply, add, multiply, add. And just by chance, I got lucky enough that I did find a 0 because my remainder here on the end is 0. So my new polynomial is x squared plus 4x plus 3 equals 0. Okay. Why does it not want to write part of the time today? I already know 2 is an answer. Now I'm looking for the other answers. X squared plus 4x plus 3, you either have to factor it or use the quadratic formula. And since it will factor, I suggest factoring. Multiples of 3, factors of 3 that add to 4 would be 1 and 3, and they both have to be positive to give me that positive 4. So if I set x plus 3 equal to 0 and solve for x, x plus 1 equals 0 and solve for x, and there are your 3 solutions. Now pay attention in my math lab, because usually it'll say, what is one rational root? And you would list one solution, like 2. And then it says, what are all the rational roots? And then you would list all the rest of them, including the 2. Okay? Find all the zeros of this polynomial. Again, it's the factors of the constant over the factors of the leading coefficient. To get 3, it's either 1 or 3, and to get 1, it's just 1. So doing our division, we got 1, and we've got 3. Okay, what do we want to try? I'm going to try -1. With 1, 7, 11, and -3. Remember, if you're missing a power of x, that you have to put a 0 in there, which I'm not missing one in this one. Bring the first number down, multiply, add, multiply, add, multiply, add. I didn't get 0, did I? Let's try a -3. First one comes down, multiply, that's a very bad 3. Add, multiply, add, multiply, add. There I go, I found my 0, didn't I? So x squared plus 4x minus 1. Now there's no factors of 1 that will subtract to 4, so on this problem, I have to use synthetic division. Or I'm sorry, quadratic formula. We've already done synthetic division. So remember, your quadratic formula is -b plus or minus the square root of b squared minus 4ac all over 2a. So negative b, and then the square root of b squared minus 4 times a times c all over 2 times a. 4 squared is 16. Negative 4, 1, and negative 1 are plus 4. So that gives me a 20 under the radical. But 20 breaks down into 5 and 4, and the 4 is 2 times 2. So since I have a pair of 2's, that 2 comes out and the 5 stays under. All three of these numbers are divisible by 2. So divide them by 2. So your other two answers is negative 2 plus the square root of 5, negative 2 minus the square root of 5. Okay? Okay, one more. Okay, so I've got the factors of 24 over the factors of 1. Anytime you're dividing by the factors of 1, okay, it's really not going to change your factors because you're just dividing by 1. So we've got to get 24. It could be 1, 2, 3, 4, 6, 8, 12, and 24. Okay? Okay. I'm going to try 2. Now in this problem, you notice there is no x to the third. So for the third spot, I have to put a 0. Otherwise, it will not work. Okay? So bring down your 1, multiply, add, multiply, add, multiply, add, multiply, add. And I got lucky and found a 0 right off the bat. Okay? Now, if you was to graph this in the calculator, you would see that at 2, it touches the x-axis and turns. That means it's a solution twice. Okay? So this is an x cubed. So if I take 2 into that solution, 1, 2, negative 2, and 12, bring down my 1, multiply, add, multiply, add, multiply, add. Now I have x squared plus 4x plus 6. Are there factors of 6 that add to 4? No. So we have to use the quadratic formula again. Negative b plus or minus b squared minus 4ac all over 2a. 4 squared is 16, and then we have minus 24. So 16 minus 24 is a negative 8, but we can break 8 down. So we got a pair of 2's that'll come out. So now I have negative 4, 2. Remember, a negative under the radical comes out as an I. Square roots of 2, all over 2, and I can divide that. So I get negative 2 plus or minus I square roots of 2. And I can't forget my 2 from the previous slide. And that ends the lecture on 3.4.